do.
Okay.
Instead of finishing out my school year at my regular high school, I decided to do online school so I can possibly graduate earlier. So I'm going to be working on math this summer.
Sounds good. Be happy to help you.
All
Refresh.
right.
Refresh.
So is there a way I can share my
What kind of
screen?
math? What'd you take last semester?
Well, I'm still on second semester junior year.
Okay. So, do you have problems you can verbalize?
Is there a way I can share my screen? That's probably the easiest thing.
There is. Unfortunately, it's a little cumbersome. Here, let me try it. I can make you the presenter. Let's see
All right.
what you have on your screen. Okay. You know what? This is going to be easier if you verbalize it.
Okay.
Okay. So let me
So
make
I'll stop
myself the
sharing.
presenter again. Um, you can verbalize these easy enough, and it just works better that way. It's so hard to toggle back and forth between screens. Takes like 5 mouse clicks. That
Yeah.
and I don't have access to my drawing pad if I'm on your screen. So let's try it. There may be some problems where I need to look at your screen if there's a graph that needs to be interpreted or something. But for the first
Yeah.
page that you showed me right there, we can certainly do those by having you verbalize.
All right. So for the first one, it says determine the zeros of the function
Mhm.
2x squared minus 4x minus 6 equals 0.
All right. The fact that yours is multiple choice doesn't affect anything. You got to solve these. Having it be multiple choice doesn't help.
Yeah.
Okay. So how do we solve this problem?
You put 6 on both sides first?
No, actually, this is unique in that this is a quadratic. And it's a quadratic in standard form where everything is on the left, zeros on the right. So what we're going to do is factor it into two linear terms, and then we can set each term equal to 0, because the only way two terms multiplied together are equal to 0 is if one of them is equal to 0. In other words, I cannot solve that quadratic right now. I don't know how to do it. But if I can get it to be the product of two things, then I can do it. Now,
All right.
the very first thing in factoring is always to check and see if there's a greatest common factor. Because frequently you can make the problem a lot easier if you can find a
In
greatest common
in
factor.
this case, is it 2?
Yeah, so let's factor out a 2. What's it like?
So it'll be x squared minus 2x minus 3.
Yeah, now see, this quadratic is much, much easier to factor than the original one. Anytime you
Yeah.
have a 1 in front of the x squared, it's easy to factor. It's when you have
Yeah.
numbers other than 1, like 2 or 3 or 4, that makes it a little more difficult to factor. So, first of all, do we need that 2 that we factored out? Oops, excuse me.
Um,
Can we get rid of it?
by dividing on both sides.
Yeah, so we don't need it. I'm going to divide both sides by 2. Okay, now we have this problem, which is easier still. So now it's a simple factoring problem. And factoring is probably one of the most valuable skills you can have at this level of math. You got to be able to factor. So,
Okay.
work me through the steps of factoring there.
Well, so you want x is the first.
That's the first step right there.
Yeah.
In other
Put
words,
x
what
on
you
both.
don't want to do is try to do the whole thing in your head in one step.
Yeah.
Not the way to do it. The way to do it is to separate the x squareds, like we just did. Second step, determine both signs. What do both signs have to be?
Negative.
No, that's not going to produce a -3. Remember what
Oh,
factoring is. Factoring is foiling in reverse. And when you FOIL two things, this term is always comes from the last two terms multiplied together.
so
So
they
they
both have to
be the
be,
same
one
sign.
of them has to be a positive and one of them has to be a negative.
Exactly. And since I have an x and an x, positive negative is the same thing as negative positive. So I only have to
Yeah.
write it once. Third step.
Well, it's going to be +3 times -1.
Yeah, the third step, let's formally verbalize it. Factors of 3 that subtract because of that negative sign to the number 2.
Uh-huh.
So that would be 3 and 1. Only factors of 3. And
Yeah.
stick the larger factor with the sign of the middle term. So the 3 goes there. The 1 has to go there. Now we're almost to our answer. How do I solve it from here?
So we're just looking at the 3 and 1, correct?
Yeah, we're down to this. We got two things multiplied together that are equal to 0. What does that mean?
That means that each of them must equal 0.
Okay, not quite, but close enough. That is the way you solve it, is by setting each of them equal to 0. But the actual law says only one of them has to be equal to 0.
Okay.
In this case, we're going to set that one equal to 0, and we get what? X equal -1. And we're going to set this one equal to 0, and we get x equal 3. And when you plug those two solutions back into the original quadratic, they both work. So
Yeah.
both of them are valid. You will eventually come across problems where sometimes you produce an extraneous solution and one of them is not valid. But the fundamental rule of algebra says that if you multiply a times b and it's equal to 0, then either a or b or both have to be 0. You can't
Yeah.
have one of them not be 0. Okay. What else?
And so the answer would be 3-1 or -3-1. Or 3 -1, I'm sorry.
Well, I can't remember what the two things were. I erased them.
It's okay. Hold
What was
on.
the original? Here, I can do it real quick. Let's see. It was x plus
2x
3.
squared minus 4x minus 6 equals 0.
Yeah, it was that, wasn't it? Yeah, because we had a
Yeah.
positive 2x in the middle. Is that correct?
Yeah.
Okay. So, yeah, x equal -3 or x equal 1. Those are your two solutions right there.
Yeah.
Okay?
All right. So for the next one, I have determine the zeros of the function, just as before. 3x squared minus 8 equals 10x.
Again, what are we looking at? What's it called?
A quadratic.
Okay, how do you solve quadratics?
Well, you need to get everything on one side. So when we subtract 10x from Both sides.
Very good. And put it in order. Put that 10x in the middle where it belongs.
Yeah.
And 0 on the other side now.
Yeah.
So now, again, it's a factoring problem. Notice this time you cannot pull out a greatest common factor. There is no number that divides into 3, 10, and 8. Okay, so this is a little tougher factoring problem. These kind of factoring problems become trial and error. But I highly recommend we do the same method. Okay?
Yeah.
So split up that. That's always step one.
All right, so divide by 3.
No, you got to split it up into two things. Both of them should have x. And when they multiply together, they're equal to 3x squared.
I'm not sure what would multiply to. It's got to be 3x and then 3 and x squared.
Nope, 3x and x.
Oh yeah, because x times x is x squared.
Yeah, and remember, you get this term that I have circled from multiplying that by that only. Nothing else contributes to it.
Yeah.
So splitting it up is rather easy. Okay, you just have to split it up so that those things multiply together back to get that. It's the middle term that's more complicated, because the middle term comes from a couple of things. But the last term, this -8, only comes from the last two terms multiplying together. So the first term and the last term, you use that to factor it. What's the second step?
Oh, we need to get numbers that multiply to -8.
That's the third step. And actually, that no longer applies. But let's take it in the order of the steps. What are both signs? That's the step everybody forgets, and that's the reason people have a problem with factoring, is because they do not do step 2.
Is it positive and then negative?
It is. But the problem with this one is that positive negative is not the same thing as negative positive, because the x's have different coefficients.
Yeah.
So when you have this situation, you have to allow for both a plus minus or a minus plus. Okay?
Yeah.
Now, the next thing we're dealing with are factors of 8. Give me factors of 8. There's one.
4 and 2, 8 and 1.
That's it. Okay? Now, what I'm going to suggest to you, this is a trial and error process at this point in time. But we have 8 different combinations. I can put the 8 here, the 1 there, the 1 there, the 8 there. There's 4 combinations, the 8 and 1.
And then the goal is that
4 and 2.
do they subtract away from each other to equal -10x?
No, you can't say that any longer. That only works if you have an x and an x.
Okay.
We have a 3x and an x. So the moment you do not have x and x, that rule goes out the window. And you just have to figure out how to produce this middle term. You have to use a combination of those factors in order to produce -10x.
If I put 4 on the left side, it'll multiply to 12x. So whatever is in the other parentheses, can that subtract from it to equal 10x?
Here's the way I do it. Now, you can do it a different way, but the way I do it is I arbitrarily start with the two factors closest together. 4 and 2 are closer together than 8 and 1. And I arbitrarily put the 4 there and the 2 there. I am not doing any advanced thinking here at all. And what does that produce in the middle?
That equals 12x, 14x?
No, hold on.
Or actually just
you get the middle from the insides being multiplied together and the outsides. So the what I call the double smiley face, okay? The insides produce plus 4x, correct?
Correct.
What's the outside produce?
-6x.
Add them together.
You get not 10 at negative 10x.
But it's important to go ahead and add them together, because here's what happens. If I choose to move the 4 down and the 2 down, is all I do is change the sign. I don't change the number. You understand what I'm saying? In other words, if
Yeah.
I put, okay, the next thing I'm going to do is 4 there and 2 there, well, is all that does is changes it to a plus 2x, always. So I don't need to try that combination. That's what I'm saying. In other words, by trying this first combination with 4 on the left and 2 on the right, I've eliminated 2 of the solutions, or 2
Yeah.
of the things I have to try. So the next thing I'm going to try is put the 2 on the left and the 4 on the right. And let's see if we at least can produce a 10. If it's a negative 10, perfect. If it's a positive 10, we'll know is all we got to do is move the thing down.
2x
plus 2x, and I
12.
recommend writing the plus in front of it.
Minus 12x.
Okay.
Which equals negative 10x.
That's our answer. We found it. Had
So
it
positive 2.
had it been positive 10x, then I would have just moved the 2 down to the negative sign and the 4 down to the positive sign. So I ended up with 8 possible combinations, but I only had to try 2 of them to get the answer.
So the final answer, as we put it together, will be
Let me erase some of the stuff I got here. I don't need that negative sign anymore, or that positive sign, or any of this. But that double smiley face is a critical part of figuring it out.
yeah.
So now, if that's equal to 0, then what is true?
Then both of them must equal to 0, or one of them at least.
One of them at least. In a typical quadratic, both of them are always set to 0, and you always end up with 2 answers. Where you start running into quadratics where you have a solution that is not equal to 0 is when you get into logs or radical signs or absolute value signs. Then sometimes you produce 2 solutions and one of them is not valid. Okay. With a normal quadratic, it's almost always both of them are valid, and you don't even need to test them. Okay. So tell me what the 2 answers are. Let's start with the easy one.
X minus 4. It's going to be positive 4.
What's the next one?
3x minus 2 equals 0. Minus must be. Hold on, I gotta lay it out in my head.
Well, you can do it on paper. You should have some scratch paper in front of you.
So 3x plus 2 equals 0.
Okay, now solve that equation.
And then the first step is to subtract 2 on both sides.
Okay, so you have 3x equals negative 2.
And then I don't know how to get 3x, so I guess it must.
Okay, the way to solve algebra equations is your final answer is going to be x equals something, right?
Oh, I know what to do. Divide 3 on both sides.
Get rid of anything that's with x, and you get rid of it by doing the opposite of what it is doing. That 3 is multiplying right now. So we divide. We do the opposite.
We get negative 2/3.
Yeah.
4.
And in fact, the first time we got rid of the 2, we did the opposite. We subtracted 2 from both sides. So that's the way to solve all equations. You always just do the opposite of what the thing next to the x is doing.
Yeah.
All right. What else?
All right, so we have determine the zeros of the function x squared minus 7x minus 8 equals 0.
Okay. This is what I call an elementary quadratic. It's in perfect form, and it has a 1 in front of the x squared. So we're going to be able to do this one using those old rules that you can use.
So
do it step by step.
First couple are going to be x. And then your signs, both, one has to be negative, one has to be positive, so it would be positive, negative. And then it would be 4 and 2.
Factors, verbalize it.
Oh, 8 and 1 will be a factor, 4 and 2 will be a factor.
What you're looking for is factors of 8 that subtract, because of that negative sign, to the number 7. What factors of
8 and 1.
Okay. Now, so those are my factors, but I still got to figure out which one to go with the negative sign, which one goes with the positive sign.
8 will go with, or actually,
look to the sign.
They have to subtract.
Huh?
They have to subtract to negative 7, right?
Not to negative 7. They have to subtract to 7. Well, these subtract to 7. But now the thing is,
8 is going to be positive and 1 is going to be negative.
Right. And how you decide is you take the larger factor, 8, and you put it with the sign of the middle term, which is negative. So the 8 goes there because there's a negative sign in front of the 7.
Yeah.
Okay. Now, I don't need to check it because it's so simple, but maybe not so simple for everybody, so let's check it. The inside produce plus 1x, the outsides produce minus 8x. Add them together, you get your middle term. We did it correctly. In other words, if your life depended on it, you'd want to do this last step, right? Somebody said you're going to die if you get the wrong answer. You're going to do this step. You are going to make sure that that middle term is minus 7x.
All right.
Okay.
So
now give me the solution.
Oh, the solution will be negative 1 and 8.
You got
it. The next question is, what is the vertex of the function x squared minus 6x plus 8 equals 0?
Okay. Quadratics are always what shape? If I'm going to graph a quadratic, what are they called?
They're a parabola.
Correct. Okay. So, however this thing graphs, does it graph up or down?
Up.
Correct. I'm just going to draw an imaginary parabola in there where I think it might be. They're talking about this point right there. That's the vertex.
Mm-hmm.
Now, the one thing I know about the vertex is it's halfway between the x-intercepts.
Okay.
Okay. And if I can factor this quadratic into x minus some number times x minus another number, that's intercept format. In other words, intercept format is y equals a times x minus p times x minus q. Okay, where p and q are the x-intercepts.
Yeah.
Now, I can see, I'm going to do it fast, although, I don't know, maybe you should do it. Factor that quadratic.
So we start off with x's in the first places. Both are positive.
No, they're both the same.
Oh, wait, because negative 6x, yeah. So
both the same, and whatever the middle term is. Once you decide they're the same, whatever the middle term has, that's what they are.
Yeah.
And now we want to verbalize it.
So I need two numbers that
factors of 8.
Factors of 8 that subtract
Not
6.
subtract. In this case, we have a plus sign there.
Yes.
So they have to add to
Yeah.
6. Not -6, but 6.
So it'll be 4 and 2.
Yeah, this one's easy, and it doesn't matter which side goes on which. In other words, when you have the same sign, you eliminate step 4. It's just a simple 3-step quadratic.
Yeah.
Okay? So that tells me some things. Because notice that I now have it in this format. So where are my x-intercepts?
-4 and -2.
No, they're the solutions to this quadratic. It's not negative.
Oh, 2 and 4.
2 and 4, right there and right there at 2 and 4. And I know how this thing kind of looks, right?
Yeah.
The only thing I don't know is this point here, but what do I know about that point? Do I know the x?
It's right in between those intercepts, so it'll be 3.
Yeah, so I know the x value of the vertex.
Yeah.
How do I get the y value?
I'm not sure.
Plug it into the equation. In other words, plug in 3 to this equation, and you get 9 minus 18 plus 8, correct?
Yes.
Which is minus 1. That's the y value.
Okay.
So that is the vertex right there. Not only do I have the vertex, but I have 2 additional points, x-intercepts, and that's all you need to define a parabola or quadratic, or 3 points.
Yeah.
Okay. Now, the reason the standard formula looks like this, has an A in front of it, is because this thing could be compressed. In other words, this thing may not look, in other words, I can go through those x-intercepts, but if it's a much narrower parabola, I get a different vertex, right?
Yeah.
So stick a 3 in front of that, like that blue 3, and you get a stretched parabola that's vertically stretched, which gives you a different vertex. So this sometimes is not 1. In our case, it was 1. A was 1.
Mm-hmm.
Okay? But sometimes A will be a different number. And
Yeah.
it'll place the vertex slightly differently, but it's still a factoring problem. Actually, it's not totally a factoring problem. There's one other way to do this problem, and that is to put it into vertex format by completing the square. Have you had to do that?
Yes.
Let's do it, just to refresh you. You're going to get tested on that, correct?
Yes.
Okay. Okay, let's write down what our vertex was. 3 comma minus 1. Okay?
Correct.
Now let me erase everything else. And we're going to solve this problem differently this time. And I don't know if it's harder or easier. I suppose when you come with a quadratic like this you can factor instantly, then that's probably the way to go, is to just factor like we just did. Sometimes it won't be that easy, and you'll want to do it a different way. There is vertex format. Okay, here's vertex format over here on the left. Y equals A times x minus h squared plus k. You want to memorize that. That's actually probably the most important format.
Seems very familiar.
Yeah, this one, the reason it's so important is because it immediately locates your vertex. The vertex is h and k.
Correct.
Okay, so how do we get this to look like this? Well, let's complete the square, and I'll show you how to do it. First thing you do is you leave everything on one side. Notice that all of that's on one side.
Mm-hmm.
Okay. And you separate out the terms that have x in them, like this. And you leave enough room to complete the square. Have I changed anything?
No.
Okay. Now let's complete the square inside the parentheses. How do I complete the square?
I have totally blanked on it.
You take half of the coefficient of the x term and square it.
Okay, so the coefficient of the x term is 6, and so half of that is 3. 3 times 3 is 9.
Okay, so I'm going to add, and you're always adding it, because even if it's a negative number, when you square it, it becomes positive. Okay, hold on a minute. I'm going to add plus 9. Now, did I change anything?
No.
Yeah, I just added 9.
Oh, well, yeah, so you have to add 9 on the other side.
Not the other side. Let's subtract 9 on the same side. Same thing as adding 9 to the other side.
So subtract 9 outside of the parentheses.
Exactly, right there.
So
Okay?
that becomes -1.
Well, the main thing that happens is because we completed the square, we can always write that in this kind of terminology. Notice that is what we're looking for.
Yeah.
What's this combined to?
-1.
Now we have it in perfect vertex format. Where's the vertex?
Vertex is -1 where it is supposed to be.
Start with the x coordinate of the vertex.
3.
Correct. Notice the general format is x minus h. And we have x minus 3. That means h is a positive 3.
Correct.
So h equals 3, k equals -1 because it's a positive k. Okay? And that's the same vertex as we got the first method. Now, this may seem a little harder because most students don't like completing the square. Once you get used to completing the square, it's not really harder. I don't find it to be. Notice that I didn't have to do anything that I had to do. The first time we factored it, we were able to solve for the x coordinate of the vertex. Then we had to plug it back in and calculate the y coordinate. So there was actually quite a bit of math to do in the first method.
Mm-hmm.
This method, there was basically, I had to add 9 and subtract 9 from the same side. And then I had my answer. Well, and then I had to know that because I completed the square, I can always write that as an x minus h squared. That's the whole point of completing the square, is so that you can write it as a linear term, x minus 3 squared. You will always be able to do that. It won't always be x minus 3, but it'll be x plus or minus whatever half that was. You with me?
Okay.
Okay. So those both methods are going to be, you're going to get some problems that can't be solved factoring it. What if I made that a 7? Okay. What if that was a 7 instead of a 8? Now there are no factors of 7 that add to 6.
We can do what we did with the 8.
Well, we could complete the square is what we could do to
Yeah.
solve this. Or we could use the quadratic formula. And guess what? The quadratic formula was derived by completing the square. So using the quadratic formula is a method of completing the square. You just don't have to do all the legwork to come up with it. They give it
Yeah.
to you, and it's definitely something you want to memorize. I'm sure you have to memorize that. Is that correct?
Yes.
They don't give it to you?
It depends.
What is it? Tell me what it is.
The which one?
Quadratic
Which formula?
formula?
Oh, X. So I don't know what unit to use. It would be
You don't
um
need any units.
X.
It's just, here, I'll get you started. Minus B.
Oh yeah, plus or minus A.
Well, here's what it is. Now, very important you memorize this. You're going to take a lot of tests to prepare for college, and you have to know this, and they do not give it to you.
Okay.
Now, because of that, a lot of schools will teach it to students in a song, much like you learned your ABCs, and the way I still remember my ABCs. If you ask me what comes first, I or J, I probably have to sing the ABC song. A, B, C, D, E, F, G, H, I, J. I comes before J, okay? So those tools are extremely helpful. Now, I don't remember the song for the quadratic formula. I tutor enough math that I just memorize it and never forget
Yeah,
it.
yeah.
But if they taught you a song, use it.
Okay.
Okay, it
I'll
goes
work on
something like
memorizing it.
opposite b plus or minus the square root of b squared minus 4ac all over 2a. Something like that. I got the tune totally wrong, but try to figure out a way to memorize it. Okay?
Hmm.
Now, in that problem we just had, where it was an 8 and I changed it to a 7, so if I'm solving for the zeros of that, and I'm going to use the quadratic formula because I cannot factor it,
Hmm.
what's A, B, and C?
Um,
What's A?
A is gonna be
Coefficient of the x squared term.
1 or 6, I'm sorry.
Nope. You were right the
Oh,
first.
the X, oh, coefficient of the X squared. Yes.
B is
1,
the coefficient of the x term.
which is -6,
And C is the constant.
which is 7.
Plug each of those in to this formula and you'll come up with the zeros of that quadratic.
Okay.
Okay? In other words, it would be positive 6 plus or minus square root of 36 minus 4 times 1 times 7. I recommend doing it this way. All over 2. Now solve that part, which is 28. So we have 36 minus 28. So now we have 6 plus or minus the square root of 8 all over 2. You with me?
Yep.
Now I'm going to change the square root of 8 into 2 root 2 because that's what it
Okay.
simplifies to. It's the square root of 4 times the square root of 2, which is 2 root 2. Now I can divide top and bottom by 2, so I get an answer 3 plus or minus root 2. That are the two zeros for that quadratic right there.
Okay.
And that's how you do the harder ones. And now you can use the quadratic formula on any quadratic. If you can't figure out how to factor something, just use the quadratic formula. It always gives you the right answer.
Yeah.
If you could have factored it, you'll end up with whole numbers down here. You won't end up with radical signs. That's what it tells
Okay.
you. If you end up with a radical sign, that means you could not have factored it. But if this is 3 plus or minus 1, then my answers are 4 and 2, right? And that's
Yeah.
what it would be if I go back and change that back to an 8 and apply the quadratic formula to it. I would have gotten 3 plus or minus 1, which were the two answers, right? 4 and
Mm-hmm.
2. So both of them will always give you the correct answer. Only reason we do factoring is because it's a little quicker than applying the quadratic formula once you get the knack of factoring. And they kind of force you to get the knack of it. Most of
Yeah.
Algebra 2 is factoring. You get right down to it. You cannot go wrong by practicing factoring. If you're looking something to practice to take your test, just get a bunch of practice problems on factoring and go through and make sure you know how to factor well.
Okay. Next thing I want to go over is finding the minimum and maximum values of parabolas.
Go ahead and give me one.
But it's a pictures of parabolas, so like on a graph. So
Okay, here, let me tell you what.
so if you could just make one up.
Yeah. Let's say they have a parabola like that. If it opens up, the only thing you have is a minimum right there. Where does that come? At the vertex.
Okay.
If it's a parabola that opens down, you have only a maximum, which also comes at its vertex. That's why you have so many questions, where is the vertex? Because parabolas are the way projectiles move. You throw a ball in the air to your buddy, it moves in a parabola, parabolic motion. So if you want to figure out how high that ball goes and you know the equation of the parabola, all you got to do is solve for the vertex. And it tells you not only when it comes, but how low it is or how high it is.
Okay.
Okay. Now, we got a couple things we can do. You can take I can make you the presenter. Let me do that for a second, just so I can see what you're looking at. Is that okay?
Okay.
All right. And the question is on this one, does the function have a maximum or a minimum? What does it have?
It has a minimum.
Yeah. Why does it not have a maximum?
Because a maximum is the maximum
all the way to infinity.
Yeah.
Both sides go all the way up to infinity. So
all the way to infinity.
No maximum. Yeah. You could say the maximum is infinity, but that would act like infinity was a number, and it isn't.
Yeah.
Infinity is not a number. It's a concept. It is growth without bound. Okay?
Mm-hmm.
Okay. What is that value?
This is -9.
Correct. And they're asking for the y value there. Okay? That can be kind of confusing because sometimes they will ask you where on the x-axis that minimum occurs. What would the answer be here?
-9.
No, that is the minimum.
Oh, 3.
Right. So you got to be a little careful on how they're asking the question as to whether they're asking for what is the maximum or minimum or where it occurs. Okay?
All right. I did have a couple. Range and domain are the next ones.
Okay, let's start with the beginning one. Let's start with domain.
Domain, okay.
Oh, that's lower. Huh. Reason you start with domain is because it's the easier one.
Okay.
It's always easier to figure out domain. What is the domain of all parabolas that go either up, down, or point up, or point down?
Isn't it negative infinity, infinity?
Yes. In other words, there is no value of x that it cannot be. That's the way to think about domains. It's not so much what it can be, it's whether it can't be something. And with this parabola, it doesn't look like it goes to negative infinity on the x-axis, but it does. You go high enough up on the left side of that parabola, and eventually you go to negative infinity. Same thing going to the right. You go to positive infinity. Okay?
Correct.
What's the range of this function right here that we're looking at?
Now the range is for the y values, correct?
Correct. Now,
So it would be,
so you can approximate. They didn't ask you that on this one, and the reason they didn't ask it to you because they didn't put it on a grid line. In other words,
probably 5 and -2.
A little bit below -2. Range, you want to get your eyes going up and down only. So what's the lowest value it can be?
The absolute lowest value that on the y-axis?
Uh-huh.
0.
That's what range means. It's what is the range of the y values. Domain is what is the domain of the x values. So when you're looking at
the
domain,
lowest
you want
possible
to get
value
your eyes
could go
going
is
left to right.
-2.
What's that?
The lowest possible value it could go to is -2.
Well, -2 1/3 maybe, right?
Yeah, probably.
Okay. So the range is -2 1/3 to what?
To +5, roughly.
Infinity.
+5 and maybe 1/3.
Oh, infinity. It goes all the way up. Those
yeah, because it
go all the way up to infinity. They not only go to infinity right and left, but they go to infinity all the way up also.
Correct.
So the range is -2 1/3 to infinity.
Yes.
Okay. Now, have you learned interval notation?
No, I have not.
Okay, then I will not introduce you to it. Yeah, let's cover all of these because we can do all of these. Let's just start with the first graph. I didn't mean to say start with domain. Let's just start with your first problem.
The answer written down. This one was the domain.
Okay, so
we were just
yeah. Let's just go up until we see the first one, and then we'll go down on all of them.
All right, so this should be
okay. What's the range of this one?
So we go from the lowest value, which is going to be roughly -1.5.
No. Where are you getting that from? Ah, you're looking at the x. You got to get your eyes to go up and down when you're talking about range. You're not looking left and right.
Oh, okay. So we're going to be looking at this.
Right. What's the highest value it can be?
1.
What's the lowest value it can be?
Infinity.
Negative infinity.
Negative infinity.
And always start from the bottom. In other words, when you're saying what the range is, you don't say 1 to negative infinity. You say negative infinity to 1.
Okay.
Can it be 1?
Yes.
Yes, it can be. There's the value right there at 1. When x is 2, y is 1. Okay? So you would actually say that it goes from negative infinity to 1, and it can be 1. So you could say y is less than or equal to 1. Not just less than, but less than or equal to 1. And that describes the range perfectly. Y is less than or equal to 1. Okay, let's go to the next one.
I think we might have already covered this one.
Yeah, domain on parabolas are easy. Just say all real numbers. Negative infinity to positive.
And to do the domain, it is the
left to right.
Yeah. Did we already do this one? Yes, we did.
Yes, we did.
So we'll go up and cover a couple of these ones that have nothing to do with this one, right? These ones right. These ones right here, the ones we haven't done.
Right. So let's do them real quick. That's what I was.
Yeah.
Come, I'm not seeing it. Question 5. I don't see a graph on question 5. Oh. Let's go do question 5.
These are different ones.
Can you back up to 5? Let's cover 5.
I think we already did 5.
Okay. Then let's do 6. Let's go to 6. Okay. So This says an object is launched upward at 64 feet per second from a platform that is 80 feet high. What is the object's maximum height? And use the equation. The height is 10t squared. Okay, I need to write on this, so I'm going to switch back to being the presenter, and I'm going to have you read those to me.
Okay. Looks like we only have time for this one, so I'll pick whichever one looks harder to me.
That first one looked pretty hard. Let's do that one.
Okay. An object is launched upward at 64 feet per second from a platform that is 80 feet high. What is the object's maximum height if the equation of height, h, in terms of time, t, of the object is given by h, t, equals negative 16t squared plus 64t plus 80?
Okay, as I was saying, all objects that are thrown through the air follow parabolic motion. And they all have an equation very similar to this. Okay, this minus 16, that comes from gravity.
Yeah.
This 64 comes from the initial velocity, which they give us, 64 feet per second. That's always the coefficient of the t term. And the final constant is the height that it starts at. That's why it's 80. Okay? So they have given us a perfect quadratic. And what are they asking?
They're asking us, what is the maximum height of the object?
Okay. So what we have here is going to be a parabola that points up or down.
It's going to be pointing down because it's going to be a maximum value.
So that's a reasonable drawing of our picture.
Yeah.
Starts at 80 feet high. It's launched from a platform that's 80 feet high. Well,
correct.
Here's the maximum height. Now, there's two points to that thing. There's the x-coordinate, or in this case, the t-coordinate, because our horizontal axis is t, and our height is h of x, or h of t, excuse me. Okay? So we got to figure out where the vertex is, and we can answer both questions. We can answer what the maximum height is, which would be this value, and we could also answer when it occurs. How many seconds after it's launched?
Well, it's asking what the maximum height of it is, so I guess that's what we'll
So we have to determine that only, but that's kind of, we have to know the vertex to determine that, right?
Yeah.
So when you are given a quadratic like this, there's another way to solve for the vertex. First thing you can solve for is the t-coordinate of the vertex. Do you know what that formula is? First half of the quadratic formula.
First half of the quadratic formula is just a minus b over 2a.
That's the first half. Okay, you can think of it as being the first half. I mean, you have plus or minus the square root of b squared minus 4ac on top, but you can think of this as being the first half. It's one way to memorize. Or once you memorize this, it's a way to memorize the quadratic. Okay? So what is the t-coordinate of the vertex in this case?
The t-coordinate of the vertex, and we're taking this from the equation they've given us.
Yes. What's negative b?
So negative b will be 64.
What's b?
64.
What's negative b?
It's negative 64.
What's 2a?
2a, so isn't a going to be negative 16?
Uh-huh.
So 2a is going to be is going to be 32.
Negative 32.
Oh, it still applies to be a negative.
You see why?
Yeah.
A is negative 16, so 2 times negative 16 is still negative 32. Okay.
Yeah, I see that.
Now both negative signs cancel, and you end up with a positive 2. So that's when you're going to hit your maximum height. We had to figure that out first before we can actually figure out what that maximum height is. Now, what I'm really needing is the y coordinate of the vertex. How am I going to get that? That's what they're asking for.
Yeah.
I know the t coordinate.
The second half of the equation?
No. Plug that 2 in for t. We know that's
Okay.
where the maximum height is going to occur.
Oh, yeah.
So if we plug in 2 for t here, it'll tell us what that h of t is, and that is the height of the ball at 2 seconds. And we've already determined that the maximum height's going to occur at 2 seconds.
So if we plug in 2 for t, the first is going to be the t squared. So that's going to be 2 times 2, which is 4, which is negative 16 times 4, which is negative 64, plus 64 times 2, which is 128, plus 80. So 208, negative 64 plus 208, which is 144.
That's the height. That is at 144 right there.
144, which would end up being the final answer.
Yes. Now, they could have just as easily asked, when does the final height, or when does the maximum height occur? And if they ask that, the answer is 2.
Because it's slightly different, but it's a completely...
Yeah, you end up needing both. In other words, that's why they spend so much time asking you where the vertex is because on
because they want you to have to do it the way they want you to do it.
Yeah, I mean, you'd want to know if you were inside a building, you'd want to know whether you're going to hit the roof or not. So here's a classic case where you can use quadratics to determine something.
Yeah.
In life. And you'd want to know whether you hit it at exactly 2 seconds. Now, notice that if I were to, whenever you have a quadratic, I'll let you go here. We got about a minute. Whenever you have a quadratic, you get 2 answers.
Yeah.
Okay? Well, I only got 1 answer. I only solved for this 2.
Uh-huh.
But there actually was, here, you weren't asked this, but frequently you will be asked as to when the ball hits the ground. Which, of course, yeah. What is that measurement right there on the t-axis? So let's say you have...
And that's just an x-coordinate.
Well, notice that it hits the ground when the height is 0, correct?
Correct.
So if I substitute 0 for that, now I have a very standard looking quadratic that I'm going to solve, and I get 2 answers. One of those answers is that one. Another one is on that side, but that's going to be negative.
Yeah.
Time cannot be negative. Not unless you're watching Back to the Future. In real life, time is never negative. So this is one of those quadratics where when you solve it, you get 2 answers and you throw out the negative answer. And you keep the positive answer, which is that one. I don't know what that number is. We didn't go through the solution of it, but you could certainly, whatever the solution produces, that's when it hits the ground.
Okay.
Okay? Nathan,
all right, thank you.
There you go. Let me just ask you, you want to work all summer? You just want to schedule whenever you want to, or you want to start something right?
That's what the plan is. Yeah, until I get this algebra course done, so maybe the next couple months.
Okay, you know how to schedule it online. I'll just let you do it.
My dad does it all, so he knows how
Sounds
to do
good.
it.
Sounds good.
All right, thank you.
You're welcome. Have a good rest of your day.
You too.